Hey guys, welcome to my channel. Over the past decade, China has launched a series of infrastructure projects on an unprecedented scale. Not to chase records, but to solve real-world problems under extreme conditions. Giant dams built on rivers with highly complex geology, ultra-long tunnels driven through mountains, fault zones, and terrain that is barely suitable for construction, and bridges suspended high above deep canyons where every design decision must begin with one question. What happens if something goes wrong? These projects have captured the attention of engineers around the world, not simply because they are large, but because they are often built in places where failure is not an option. Which leads to an unavoidable question. When resources, time, and risk are all pushed to their limits, how are these projects designed, constructed, and ultimately judged to be worth it? That's exactly what we're going to explore in this video. For years, China has carried a strange nickname in global media: the infrastructure maniac. At first glance, it sounds exaggerated, but when you look closer, it starts to make sense. Few countries on Earth have built so much, so fast, and under such extreme conditions. As the world's largest developing nation, China has relied on infrastructure as a core engine of growth, not as a luxury, but as a necessity. There's an old Chinese saying that goes, "If you want to get rich, build roads first." And over the past few decades, China has taken that idea to an almost unbelievable scale. In just over 10 years, China has built more than 45,000 kilometers of high-speed rail, more than the rest of the world combined. For comparison, Japan and Europe took nearly 3 times as long to build their networks, and even today, their total mileage is only a fraction of China's. But speed alone is not the real story. What makes these projects extraordinary is where they are built and what they are built through. Take China's high-speed rail tunnels. Many of them cut directly through active fault zones, high-altitude plateaus, and mountain systems that are still geologically alive. In some regions, engineers aren't just drilling through rock, they're negotiating with mountains that continue to move, shift, and crack under pressure. In these environments, tunnels aren't static structures, they're systems that must survive constant stress long after construction crews have left. Or consider China's mega dams. The Three Gorges Dam, the largest hydropower project ever built, stands across the Yangtze River like a wall of concrete against one of Asia's most powerful waterways. Then there's Baihatan Dam, an arch dam built in a region with frequent seismic activity, where earthquakes are not rare accidents, but expected events. Here, engineers didn't design for an ideal world. They designed for the assumption that the ground will move. Massive temperature-controlled concrete pours, real-time stress monitoring systems, and adaptive structural designs were not optional features. They were survival requirements. And then there are China's bridges. Some of them don't just cross rivers. They cross voids, deep canyons where the ground drops away by hundreds of meters, places where traditional scaffolding is impossible, and construction must happen in midair. In provinces like Guizhou, bridges are not architectural statements. They are lifelines. Guizhou alone has more high bridges, defined as bridges over 100 meters tall, than the rest of the world combined. This is not because China wanted records. It's because the terrain offered no alternatives. One of the most striking examples of this engineering mindset is China's obsession with connecting what geography tried to keep apart. Across the coast, islands that were once isolated by rough seas are now linked by massive sea crossings. Bridges leap across open water, artificial islands rise from the seabed, and beneath the waves, tunnels are carved where bridges would fail. Take undersea tunnels. Building a tunnel beneath the ocean means dealing with immense water pressure, soft seabed soils, and the constant risk of leakage. Now imagine doing that not for cars, but for high-speed trains traveling at 250 kilometers per hour. That's exactly what China is attempting with projects like the Jintang Undersea Tunnel. With a diameter comparable to a 10-story building and shield machines nearly 15 meters wide, these tunnels are bored deep below the seabed, where even a small miscalculation can multiply into disaster. 2 massive tunnel boring machines advance toward each other from opposite sides of the sea, guided by China's Beidou satellite navigation system. Their final meeting point must align within centimeters. Miss by more than that, and you don't get one tunnel, you get 2 very expensive dead ends. But engineering challenges like these don't stop underground. Once tunnels are completed, engineers still have to figure out how to remove the machines themselves. There is no exit ahead, no reverse gear, so instead, machines are dismantled piece by piece underground, their steel shells sometimes left behind to permanently reinforce the structure. This is not improvisation. It's engineering under conditions where retreat is impossible. And these projects are never just about infrastructure. They reshape entire regions. When a bridge cuts travel time from hours to minutes, it doesn't just move vehicles, it moves opportunity. When a tunnel connects an island to the mainland, it ends decades of isolation. Industries relocate. Logistics routes change. Cities grow in new directions. China's Zhoushan archipelago, once limited by geography, is now home to the world's busiest cargo port, a massive offshore petrochemical base, and one of the country's most important fishing hubs, all made possible by an expanding web of bridges and tunnels. Of course, these projects come with real costs. Mega construction often means massive land acquisition, ecosystem disruption, and the relocation of entire communities. Projects like the Three Gorges Dam displaced millions and permanently altered river systems. Others raise concerns about long-term environmental sustainability, labor conditions, and transparency. These are not side issues. They are part of the equation, and they fuel global debate. Some see China's infrastructure drive as proof of extraordinary capability and ambition. Others see it as a risky gamble, where speed comes at the expense of people and the environment. Both perspectives exist, and neither can be ignored. What is undeniable, however, is that China has demonstrated something the modern world rarely sees: the ability to turn extreme ambition into physical reality at a national scale. From cross-sea bridges to undersea tunnels, from high-speed rail networks to mega-water projects, China continues to push the boundaries of what infrastructure can be. These are not just structures of steel and concrete. They are expressions of how a country chooses to confront geography, population pressure, and the limits of engineering itself. And this is why these projects matter beyond China. Because infrastructure doesn't just support civilization, it shapes it. It determines which regions thrive, which industries grow, and which societies move forward. China's megaprojects show the world one possible answer to a question every nation faces. Do you wait for the future to arrive, or do you build it yourself? This debate is far from over, and China's engineering story is only just beginning. Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted, Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments. Don't forget to subscribe and hit the notification bell. See you in the next video.